Hi guys, this video just requires a little bit of an introduction. So this started off as me deciding to look at a few graphics cards because they've been lying around on one side and I haven't looked at any for a while, and it kind of evolved from there. So what we have here hopefully is a step-by-step guide that will allow you to diagnose faults on just about any graphics card. This won't matter if they are NVIDIA or if they are ATI. They basically have the same structure. The circuits are basically the same. So if you follow this guide through step by step, each stage, you should be able at least to figure out what is wrong with the graphics card. It may be that what is wrong with it is something that you can't repair or is not easily repairable, but you should certainly know what the problem is and then decide whether it's something you can fix. This is going to take a little while, be a little bit long, so I'm splitting it into 30 minutes roughly chunks. I think that's a nice size to digest in one go. And I'll try to release each part of this all in sequence. So probably every other day is a good timescale to release these. That gives you all chance to get involved with it. I made a quite long video over 2 hours, well over a year ago, all you need to know about GPUs to fix stuff. That was more involved with understanding how the graphics card worked, because if you understand how it works, you can generally understand how to fix it, or at least have a better chance of doing that. This is going to be a bit different, so this is kind of like a step-by-step. Follow step 1, 2, 3, 4, 5. There's a certain point as you go through each step, you'll be able to say, I can eliminate certain faults, or I know at this step, this is what the problem is. And then you can look into that problem. Okay, so here goes the first part. Hope you enjoyed, and I'll see you all at the end. Hi guys, welcome to Learn Electronics Repair. I have a few graphics cards here. These were given to me by a friend. I did look at these before. One was working and one wasn't, and then for some reason neither of them would work, although I didn't actually do anything. These are, well, let's have a look and see. RX 570 ITX 4 gig, and the other one's actually the same. Okay, so we have a couple of those, and then the other one, this came in a machine from the car boot sale a couple of weeks ago. This is an R9380 2 gig, and it just didn't work. I remember the fans spun, but it didn't do anything. So let's have a look at these three and see if we can get any of them working, or at least figure out what's wrong with them. So there's a fairly simple process we can go through with any graphics card really. Just follow the dotted line basically, yeah, and this will give us a very good indication of what's happening. So first thing would be to do a visual inspection. Although we can have damage on either side of the board, if we're talking about physical damage, it's much more likely to be on this side because there's nothing to stop components getting broken off the board basically, yeah. If we have damage on the other side, it's much more likely to be something burnt. So let's have a quick look at these and just see if we can see anything obvious. Okay, so we'll just have a quick look around. And what I'm looking for obviously is any burnt components, any physical looking damage, signs that somebody's just been cooking this with a hot air gun basically, stuck it in the oven, that sort of thing. So if that's happened, you find that stickers have generally peeled up at one end or the other, or curled up. So this looks quite clean, at least. I'm just having a bit of a look. We often find what look like missing components, but bear in mind these boards are usually not fully populated anyway. They appear to make one board that was then used for various different versions, maybe with more memory or a higher powered GPU on the same board. So you'll often find what looks like missing components. And it's usually fairly easy to tell, you know, if the solder has actually been reworked or if it just looks original. To me, this just looks original. Okay, down this side. And this looks fairly good to me. So, quick inspection of that one, don't see any problem. I think it's a good idea to mark these cards so we know which one is which. So I'm just going to put like a orange mark on this one. I'll put something else on another one. Here's the next one, same sort of card. This is like a bit darkened here. This is probably underneath the RAM chips. Do we see that on the other one? No, we don't. So it's possible that on the other one, the RAM chips have been overheating, maybe telling us we actually have a RAM problem on this one. Can you see that? Like, yeah, there, okay. So that's one thing I would bear in mind with this card. Yeah, we have the same here, and again, I suspect this is behind one of the RAM chips. It's well worth checking all these little capacitors along the edge here. It's quite easy for these to get broken off if the card's been lying around somewhere. We'll just check that on the other one as well. So here we can see there's some dirt on the tracks here, but I think it literally is just dirt. But I will clean it. All these little capacitors look all right. So let's just give this one a clean while we're here. Variety of methods, a razor on a pencil, rubber, whatever you want to call it, is probably one of the best things to use. Okay. Looks a lot cleaner than it was. Although in fairness, the parts of the fingers which actually go into the slot were pretty clean anyway. Let's look at the other side while we're just here. Again, I can just give this a quick clean with the same method. You can also use a bit of isopropyl on something like a bit of kitchen roll. That works quite well also. Okay, so that's looked at the rear side of them. Here's the other graphics card, the larger one. So we'll do a similar thing again, just have a look around for any obvious damage. I mean, is that a missing diode? I don't think so. It feels smooth. It doesn't feel like something's being broken off there. It doesn't look like somebody's been soldering there, so I think that's probably okay. A little bit of corrosion in this area, but I don't think it's anything to worry about particularly. Let's have a look around. This must be the VRM, these must be the coils, basically. So this board has a little bit of corrosion on it, nothing drastic. Okay. Nothing much in this area. This is behind the GPU. Again, I'm seeing a little bit of corrosion, especially in these values. There, this green effect. That could be part of the problem, but to be quite honest, it's very difficult to clean off. And I'm not convinced at the moment that is the problem. Okay, nothing obvious on this one. Once again, we can just look at all these capacitors by the PCIe. Fingers look quite clean. So all we can really say with this one, it has a little bit of corrosion, but nothing drastic. Okay, so that's the visual inspection done. So the next thing now would be to take some resistance measurements, and we can do a few of these without actually taking the heatsink off the card, because if we find a problem here, we know probably where the problem is, or in some cases we'll know that we can't fix this. So let's have a look. So the first thing then is the power coming into the card. So any graphics card that's 75 watts or more power requirement will have connectors up here. Okay, these are 12 volt connectors. And what we shouldn't see is a short circuit or a low resistance from 12 volts to ground. So if we put the meter, it's just on ohms range at the moment. And we look from here. One side of this connector will read the resistance, that's into the kilo ohms, that's quite normal. Yeah, mega ohms even. Mega ohms. This side will be ground. So we know there's no shorts there, and we can compare this with the other one. Okay, the other input pins are over here. So here we have a 12 volt and a 5 volts. So 12 volts is on the first three fingers here, so you'd expect them all to read the same. 1.2k, just dropping slightly. No, now it's gone to 8k. That's my auto ranging meter that's causing that to do that. 42k, 4k, 5k. I'm quite happy with that. So the first three are the 12 volts, and then from this end, 1, 2, 3, 4 is the 3.3 volts, and again that reads in kilo ohms, 2.25. Let's compare that with the other of these cards. So again, I'll connect the black lead to ground. So we see the same sort of thing here the other one was doing on the 12 volt. Okay, first three pins, and then 1, 2, 3, 4 this one. Just a bit of fluff on it. 2.2. Is that the same as that one? I'm on the wrong pin there. Pin 5 is ground, by the way. It's pin 4. Yeah, 2.2, so they're about the same. And again, with this one, we can just check for any shorts or low resistances on the 12 volt in. So again, I'll just go to ground, which is the bracket. And let's have a look. What's the ground side of it? Yeah, so these will all read 0 ohms basically, and these were reading in kilo ohms or tens of kilo ohms on the other one. Let's have a look. Yeah, 3.3 and climbing up. So this is doing basically what the other one was doing. So we can say they're basically the same. So that's all the input voltage rails, 12 volts and 3.3. Let's have a look at the other card. Well, I'm on the lower magnification, so let's do this first. This has two of these connectors. So this will effectively draw more power than the other ones, or the manufacturer just made it look like that because it's more impressive. You never know. So on this, the opposite way around, you can see that the connectors nearest the PCB on this are the ones that read in the kilo ohms. And I'm not bothered what the reading is unless it shows a short or a very low resistance. So they will read the same. If they read open, that would also concern me. And again, this side, these will read 0. Or at least some of them will. Some of them are like a kind of like a sense pin, so it knows that the connector is actually plugged in. So don't be surprised if you find that that's 0. That reads open at 0. As I say, that's not unusual to find that on some graphics cards compared with this one, which is a little bit different on the ground, and it's also mounted the other way round this connector, but that's not anything strange. See, they all read 0, whereas on this one the middle pin doesn't. Okay. What's generally happening here is when you plug the connector on via the connector, it connects this pin to one of these pins, to one of the grounds, and that's how the circuitry on the graphics card can figure out that you have both connectors plugged in. Okay, it's a sense pin, the one that reads open. And it will vary from card to card, as you've just seen, but you can kind of expect to find that sometimes. You'll notice the actual fact, although they're upside down, you can tell because this has like the little key there, which holds the connector on, is on this side, and on this one they're on this side. So again, that's why it reads effectively, this one has the ground over here, and these ones have the ground over there. It is quite literally, the connector is on the other way around, it's upside down, or one of them is, whichever you want to think is the right way up. Okay, so next thing we need to do now is check the PCIe lanes. So the PCIe lanes, this is how the computer and the graphics card communicate with each other. And a single lane has 4 wires, okay, 4 wires. And there are 16 lanes. 2 of the wires are on one side of the card and 2 are on the other side. So if you look at this one, you can see that there's 2 wires coming down here. Okay, there's 2 more coming to there. Can you see them? 2 more coming to here. The ones in between are grounds, okay, and they're just for shielding between the lanes to stop crosstalk, if you like, because these have very high frequency signals on them. So you can see here we have the first lane, second, third, 4, yeah. Then we have 5, 6, just got the light, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay, 16 pairs. So that's your 16 PCIe lanes, but as I say, it's only half of them. One side are the data transmitting to the graphics card from the CPU, and the other side are the ones coming the other way from the graphics card to the CPU. So if you look on the other side, you'll see again the PCIe lanes. Now on this side we have capacitors. Can you see there? So the lane goes to the capacitor, this is lane 16, 15, 14, 13, 12. I'll just count them. In fact, you can count the capacitors: 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, but look, this one has another lane there on the second and third pin. Can you see it? It goes through the board just here, yeah? So it looks like this side has 17 lanes. It doesn't. It has 16 lanes, or half a lane, because the other half is on the other side. And this one is actually the clock. So this runs at 100 megahertz, and this synchronizes all the data transmission on the lanes. Okay? You'll see these have capacitors. So these lanes, if you look, they go from the fingers through the capacitors, and this goes up here, and they go behind the CPU, or rather the GPU. So this is your GPU here, okay? And the lanes, you can see them all coming up this way, yeah? And when we take the heatsink off, you'll be able to see them on the other side as well. Now you may wonder, why do the lanes on one side have capacitors in series with each one, but on the other side they don't? Well, the reason is quite simple. On these lanes, on this side, the capacitors are on the graphics card or the device. On the other side, The capacitors still exist, but they're on the motherboard next to the PCIe slot. And if you look at the PCIe slot on a motherboard, you will see this is true. Just to prove that point then, here is a PCI slot on the motherboard, and you can see there are capacitors on each lane, each PCIe lane, but only on one side of the slot. So this is exactly what I was trying to demonstrate, that all of the lanes or pairs have capacitors, just half of the capacitors on the motherboard and half on the graphics card. So again, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, so that logo, 9, 10, 11, 12, 13, 14, 15, 16, okay? Where these lanes go to on the motherboard will depend on the type of processor, basically. If it has an inbuilt memory controller, if it has inbuilt PCIe lanes, or it may go to the North Bridge. On this chipset, it looks like the North Bridge. Yep, you can see they all go there and under here, so you can see that's where they go to on this one. The main point of this, though, is that both sets of the wires, the 4 wires making each lane, actually all have capacitors in them. Okay, so we know there's capacitors on one side of the graphics card and not on the other for the PCIe. That matters because what that basically means is that the side of the graphics card, these lanes which don't have capacitors on the graphics card, are more susceptible to damage, okay? On this side, the capacitors effectively isolate the connector from here. And the reason for damage is normally caused because you use a mining adapter and you put it in the wrong way round. So if you do that with one of these things, what actually happens is you connect the first PCIe lane to some of the power rails on here, the 3.3 volts. Now, PCIe Express, often called PEX, PEX, you'll hear me say PEX. That is the voltage rail that powers this PCIe interface, and it's about 0.9 of a volt. So these tracks go directly into the GPU, and they don't expect to have more than 0.9 of a volt on them. If they have more than 0.9 of a volt, it just kills the GPU. And we can check very easily to see if that has happened. So the first thing we need to do on the side without the capacitors is just measure in diode mode to ground off all of these lanes. And what we expect them to be is all reading the same, okay? All reading the same. We can't say what the value will be, but they should all be the same for each lane. So let's have a look. We'll put the meter into diode mode, okay, and let's check. So we can see the first lane, it comes down here and it reads 0.751. 0.751. So those two read the same as each other, and these should all read 0.751. Now, I'm not saying they might not read 0.752 or something very close, yeah, or 0.749, but there shouldn't be any great difference. So that one's 750. 750, that's okay. Yeah. That's his ground, by the way. That's why I just caught that there if you heard it. 751. 751. So they all read basically the same. The one that's most likely to be damaged, if any, is the first one because of this business with mining adapters, okay? But it's worth checking all of them, because if there's any internal damage to the GPU from some other reason, not because of a mining adapter, you may find one of these that reads open circuit or something like that. And if you find that, then the problem is in the GPU, or it's a broken track going up here to the GPU. Most likely, when I say broken track, it's a broken BGA ball underneath it, which is not the easiest thing to fix anyway, but at least you'll know what the problem is. Now, on the other side, you'll see that we have the capacitors. So If I do the same check on here, the first lane, this is the clock, this I should be able to read. All these should read open circuit because of the capacitor, okay? So we can go here. Now you see that reads 0.810, so it's different from 0.750. And this should read the same, 0.810, yeah? Because of the possibility of a mining adapter causing the fault, it's well worth checking just this one to see if they're shorted to each other. And they're not shorted to each other. And I'll do the same actually on the other side for completeness. Just on the first line, that's the one I'm really interested in. If you want to, you can go right across the board and test them all. So again, they're not shorted to each other, okay? Much the same on this side. All the ones, if you read from one to another, just find another lane, one here. Should read about the same. Yeah, 0.466, 0.473. Little differences, but nothing major. So I'm quite convinced on this one it's not being plugged into a mining adapter the wrong way. If it has, you'll probably find either that these are open circuit or they're shorted to each other. Okay. Now the other lanes will read open. Because of this capacitor. It's worth checking them. If you have a shorted capacitor here, the card won't work, okay? Or certainly won't work properly. And it's easy enough to test this. So let's just go across the capacitors. And we should read open from each one to ground. Okay? It's very unlikely to find a shorted capacitor here. It's much more likely to find a broken one. Yeah. If you do find a broken one, the best bet is to take one of the other ones off, measure it with a capacitance meter, and then fit a replacement to the same value. I'm just trying to recall what these are. In actual fact, we can measure them anyway because this end of the capacitor is connected to nothing. Okay, so let's just check. These will vary from one card to another. I seem to remember they were about 100 nanofarads or something like that. I can't quite remember now. Let's have a look. This is not a very good meter probe. I can get on it. Okay, they're more than 200 nanofarads. Let's have a look. It's just as easy just to go to the place it's going to. Yeah, 200, yeah, 240. So these are 220 nanofarads basically. They're not always the same on all cards, so don't just think they're always 220. I have seen some that were about 100 on other cards. So back to what we were doing. We can now measure from the other side of these capacitors to ground. So this is actually just measuring internally on the GPU. Now again, they should all read the same, but they probably won't read the same as the ones on the other side. They were what, 750? What are these? 229. 229. 230. Yeah, you can see they're all the same. I expect them to read a bit higher than that, but that's what they're reading. I will certainly check on the other card as well. So I'll go across all of these and I'll do the same on the other one of these cards. And then we can have a look at the different card. What I'm looking for is any of them that just read different from the others. Okay, so they all read the same. I'll do the same thing with the other card off camera and then we can take a look at the other one. Well, both of those cards looked basically the same. The readings, there was nothing outstanding that I can say was different. So let's have a look at this one. Again, this is the first lane. Now you see this reads 692, where the other one read 750. It's a different type of graphics card, so we can expect that, okay? But they should read the same, yeah, 694, 700, it's close. I mean, to me that's close enough, yeah, 693, 700. See, that one's 697, so it just goes to show you get a little bit of variation. But I don't think that would be causing a problem. While I'm here, the first lane, I will just check they're not shorted to each other. No, that's good. You can do that with all the lanes if you wish. But to be quite honest, if you see two slightly different readings, like 692, 699, they can't be shorted to each other. Yeah. Okay, so they're all basically the same as each other. Let's go to the other side. Again, you'll see the 16 lanes with pairs of capacitors, and then you'll see this lane which doesn't have any capacitors. This is the clock. Again, this is the one that's most susceptible to damage, together with lane 1 on the other side. So that reads different, 1.057. The other one read 810. But they both read the same as each other, and they're not shorted to each other. So I'd say that's okay. I mean, without having another card of the same, to be certain, but that's a very good indication they're okay. All these should read open, and it's probably easiest just to literally just go across the capacitors like this. Okay, make sure you don't knock them off the board if they're not already knocked off the board. Yeah, I'm not scratching the board, by the way, it's just like the dirt on it effectively. Yeah, see, it rubs off mostly. Okay, so we can see they all read the same, and then this side again will read different to the other side, but they should all read the same as each other. What did that read? Well, that actually reads open. What about this one? Okay, maybe I have a bad, yeah, I have a bad ground. 456, 452, so very similar. And again, we can go across all of these. This may seem a bit time consuming, guys, but it's worth doing because you can't find faults this way, which just effectively save you wasting more time later, so the time is well worth investing. I'm just looking at the recording length, so it's taken me 5 minutes so far to go along this board on the PCIe, and that's including the time taken to talk to you guys and describe what I'm doing. Especially with this bit of corrosion on this method will certainly help you find any broken tracks between here and this GPU, or bad connections. Okay, so we can say that all three cards read okay, and I think you've now got a good idea of what to expect to find and what to look for. And we'll leave that one there, guys. So at the moment we haven't even taken the heatsink off, but we've certainly tested some things. If you have a problem where you found a short on the 12 volts or the 3.3 volt rail, that's something we can probably fix, or hopefully we can fix. It depends on what damage this caused. If your graphics card basically showed there was a fault when we were testing the PCIe lanes, and especially the PCIe clock, then you almost certainly have a graphics card that is not repairable. And that's because the PCIe lanes and the clock go directly into the GPU. There's nothing in between really to go wrong. Yeah, look for a broken track, maybe if you really have the equipment, take the GPU off, reboot it, put it back on, but that's not the sort of repair most people can do. So I think it's fair to say that if it has failed at this point, it's not something you're going to fix. You may be lucky. The other thing, you may have found some broken capacitors. Okay, so that's enough for this one, and I'll see you all soon on the next. Ciao for now, guys.